In this video, I will add few more examples for our discussion. So the book has given a lot of examples. So hindi ko na ubusin lahat ng examples sa book. It's up to you to follow the example. And so in these following examples that I will show to you is coming from problems. So I like that the book gave several problems for you to practice. So I will solve some of the problems in the book. So the book gave problem and then an answer, final answer. Okay. So much better yung final answer lang ang pinakita niya, hindi yung total solution. So for you to think. Okay. So I will be solving at, at least three problems, additional three problems. Okay, let's go. So this is problem 2.1 in the book. So I did not write the whole narration of the problem. I'll just present the given directly. So given a beam with B is 300 mm, D of 490 mm, and FC prime is 27.6 megapascal and Fy is 276 megapascal. Now, given that the ultimate moment load Mu is 100 kilonewton per meter, kilonewton meter, what is the required AS? So this is the problem. So the first solution, here comes the solution. And I'm sorry, here's the solution. And the first step for solution is to check if singly reinforced. Okay. So although we are still on the topic of singly reinforced, so most probably the result of this calculation is it should be singly reinforced. But when we reach the topic of doubly reinforced, so we need to check the section first if it is for singly reinforced and or doubly reinforced. So there will be a separate calculation if it is doubly reinforced. So most of the practical design nowadays is um, the doubly reinforced. But maybe I will explain that deeper on on our topic on doubly reinforced. But here, let's check the given if it is for singly reinforced. Actually, we can jump directly, but for the sake of explaining the concept, I need to show to you. So since we already have Mu of 100 kilonewton, so we need to check if it is singly. How can we check if it is singly? We need to calculate the ultimate moment capacity, phi mu max. Okay, and then we'll compare that if the mu if the given mu is less than mu max, the maximum capacity, this is singly reinforced, right? So if mu, the actual mu is far greater than the ultimate capacity of the reinforced concrete, then that's the time we need to add more additional reinforcement. That's why yan na yung tinatawag na doubly reinforced. So, wala pa tayo dyan. We're still on the singly reinforced, but we'll check this one. We have derived the formula for MU, that is phi 51 over 140 beta 1 FC prime BD squared times 1 minus 3 over 14 beta 1. Okay, so our phi max, our phi for maximum moment, um, for maximum condition, our phi, we use the formula 0.65. Kasi if we know that is tension controlled, so this is phi is zero point 0.9, if compression controlled, 0.60, sorry, yeah, 0.65. And then if maximum, somewhere between 0.65 and zero point 0.9, we use the formula 0.65 plus 0.25 multiplied by 800 minus Fy over 1000 minus Fy, right? So let's solve this one. 0.65 plus 0.25 times 800 minus Fy natin is 276 over 1000 minus 276. So this will result to 0.831. So this is our fee. Okay, let me just put that in the box. Fee. Um, I will add page. So once we have our fee, we know that we can solve also the beta one. So our beta one is less than 28 here, so less than 28. I mean, the FC prime is less than 28, so we expect beta 1 to be equal to 0.85. Then let's put the values here for phi m and max. Phi m and max. Okay, phi m and max is phi. Our phi is 0.831 times 51 over 140, and then beta 1 is 0.85. Our FC prime is 27.5 multiplied by B. Our B is 300 and 490 squared. 1 minus 3 over um can sorry should be 3 over 14 times beta 1 of 0.85. Okay, and then we'll divide that to uh, 1 million. So to convert the result to kilonewton meter. So the result here is phi mn max is equal to 416.86 kilonewton meter. Okay. Now we see here that our MU is just 100. So MU is less than phi mn max. So in that case, therefore this is singly reinforced. Okay? Meaning, yung kakalabanin natin na MU, yung kakalabanin natin na MU that is coming from the load is kayang-kaya lang ng ultimate capacity ng um, reinforced concrete area natin. Okay? So, kaya singly reinforced lang yung analysis. Pag hindi na kaya, malaki masyado yung MU compared to the MU max. That's the time we proceed to doubly reinforce. So, so after that, let's start with the, actually we can jump here in the calculation, we can jump here. If we know already that this is, analysis is singly reinforced. So the first step in determining the area AS is, let's check first if it is tension control. We always start with tension control. Okay, so I'll just write here, check if tension control. Kasi nga mag-change yung value ng phi. Okay, kung tension control, phi is 0.9. Kung compression control, 0.65. And then in between yung formula na ginamit natin. Before, itong nag-add lang siya sa complication ng analysis. So before kasi ang phi is always 0.9. So for beams, flexural analysis, ang phi namin is always zero point 0.9. Ngayon naga-change na. Okay? So maybe they found out in many studies. So that's the purpose of research. So let's check if it is tension control. We will check with the, sorry, MN maximum, the moment for tension control. So we have yung formula 459 over 1,600. Na daming formula. So you can simply memorize this if you keep solving problems. FC prime BD squared. Ako medyo mahirapan pa akong mag-memorize kasi it's been a while na nakaturo ako ng concrete design. So 316 B1. Beta 1. So we have the value for beta 1. So we can put the values 459 over 1,600. Beta 1 is 0.85. And FC prime is 27.5. B is 300. D is 490 squared. 1 minus 3 over 16 times 0.85. Then let's divide that to 1 million. Yeah, that's 1 million to convert to kilonewton meter. So phi mt here is equal to 407.508. What does it mean? Our phi mnt is greater than mu. So if that's the case, if phi mt is greater than mu, then this is tension control. So if this is tension control, that means phi is equal to 0.9. Okay? So let me add page. So ngayon, since ang problem natin is to determine the AS, the formula is kailangan nating makasolve ng raw. Okay? Once we have the raw, then masolve na natin yung AS kasi meron na tayong dimension. So, we have the formula for rho, if you can remember, rho is equal to 0.85 FC prime over Fy times 1 minus the square root of 2 minus, sorry, 1 minus 1, the square root of 1 minus 2 Rn over 0.85 FC prime. Okay? Now, in here, our problem is Rn. We need to solve Rn first. So, saan makukuha yung Rn? This is a formula na, sorry. The formula na Mu is equal to phi Rn BD squared. Okay? Noong una, ang ginagamit natin itong phi Rn is equal to Ru. Okay? Pasensya na sa writing. So, kaya minimemorize namin ito nung una. Mu is equal to Ru BD squared. Mhm. Okay? So, parang question siya. Ru BD squared. Yan. Ru BD squared. Taga BD. Taga BD ka ba? Kung sa dormitory. Yeah. So, ganyan lang yung technique. One of our technique before in memorizing formula is to make a story out of it. Um, just like just ang ano na to, icebreaker na lang. So when you have an angle, a triangle with theta, angle theta, and then this is C, this is A. So we to solve the area of this triangle given AC. Hindi to sa example but just ano lang. So we say dalawang army pumasok sa casino. Yan. Solve the area. Given two sides and the angle. Dalawang army pumasok sa casino. So area actually is 1/2 AC sine theta. Yan. So yan. Just one of the technique. But I will erase that one. Okay. So pang icebreaker lang yun. So let's go back. We need to solve Rn given Mu. So we have our Mu of 100 kilonewton. So we will write here 100. But that's kilonewton meter. We'll convert that to Newton mm. So we'll put times 10 to the 6 is equal to our phi is 0.9. And then Rn. Our B is 300. And then our D is 490 squared. Okay, from here we can solve Rn. Our Rn is equal to 1.542. Sorry. Then from that Rn we can solve our rho. Rho is 0.85 FC prime 27.5. Yeah, 27.5 over Fy of 200. Forgot the Fy. 276. 276 times 1 minus the square root of 1 minus 2, 1.542 over 0.85 of FC prime, 27.5. Okay, so rho is simply, let's calculate this one, 0.00578. Okay, But now, this row is we will use to calculate AS kasi ang problem natin dito is yung area of bar. But we need to check first. We need to compare this row with the row minimum. Okay, row minimum 1.4 over FY. This is 1.4 over 276. This is equal to 0.00507. Okay, so our row is greater than row row minimum. That means we will use this row. Okay? Kasi hindi tayo pwedeng bababa dun sa row minimum. That means we can solve AS now equal to row BD, row BD 0.00578 multiplied by B of 300 times 490. So the answer is 849.66 mm squared. Okay, based on the results sa book, mayroong slight na difference. But that's just probably because of the round of error lang yun siya. Okay? But that is very close. I think 1 mm lang yung difference. So that's how you compute the AS given the MU and then so in practical, actually ito na naman talagang ginagawa natin sa practice. We need to solve the AS given yung MU. Ang MU, makukuha mo ito sa structural analysis. Diba? If you have, kung meron kayong 152, yan yung mga structural analysis. 151 and 152. And then, normally, by experience, gina-assume muna yung dimension ng beam. B at saka D. Gina-assume yan normally. Okay? So, but if you are really meticulous, um, pwedeng i-design mo yung beam, yung B at saka D. Okay? But very long na yung yung method. Most of the time, we just assume the section and then calculate based on the assumption assumption natin ng section. Sa project rin, minsan yung mga architect gusto nila yung maninipis na mga section. So, kung tayo lang papiliin as much as possible, malalaki yung section para mas safer siya. Pero aesthetically, mas gina-prefer ng mga pangit masyado yung malaki, masyado yung beam. So, sometimes the architect just give limitations. Okay, yung floor to floor height. So, i-subtract mo pa yung thickness ng slab, thickness ng beam, at saka sa ceiling. So, just to make sure na mayroong enough na na clear space yung floor natin. Okay? So, sometimes the architect gives the suggested allowable depth ng beam. So, wala tayong magawa kundi to follow and then yung section ng beam ng concrete and then we'll just adjust um the number of reinforcement. Okay, so I'll move to another example. Okay, this one is pang board exam lang ito ng mga problems. What is the row balance? What is the AS max? And what is the ultimate or what is the moment capacity, MU. So given B here is 300 and D is 500. And then we have our area of bar. So ito ngayon, balik. Kanina, given ang MU, hanapin yung area ng bar. Ngayon, we have the area ng bar, 6 na 25 mm. Okay, so this is 6 25 mm bar. And then having Fy of 415 megapascal and Fc prime is 28 megapascal. So the first question is, what is the rho balance? Okay, so sorry, here's the solution. We have the formula already. I will not derive, but since we already derived the formula, 0.85 um, beta 1 Fc prime over Fy times 600 over 600 plus our Fy, right? Where beta 1 here, our beta 1 is equal to 0.85. Kasi nga, any Fc prime less than 28 megapascal, our beta 1 is 0.85. So I'll put the value here, 0.85 times beta 1 of 0.85. The Fc prime is 28 divided by Fy, 415 times 600 over 600 plus 415. We will have a raw balance. So the parang input lang yun ng value. 0.02882. So that is the final answer. Okay. Next is, let me, one, letter B. Our letter B problem is AS max. So to solve for AS max, we can solve the rho max. We have derived the formula for rho max also. 3 over 7 times 0.85 Fc prime beta 1 over Fy. Okay, so this is 3 over 7 times 0.85 times 28 times 0.80, sorry, 85 over Fy of 415. 415 ba? Okay, 415. Okay, so we have rho max, this is very simple, is equal to 0.02089. So ES max is equal to rho max BD. This is 0.02089. Okay, and we have 300 by 500. This is 3.5 mm squared. Okay, that's very simple. So now let's proceed to MU. Let us see what is MU. What is the moment capacity? Okay. So to solve for MU, given na yung AS. Okay? So pag given na yung AS, dumaan tayo doon sa rho. Let's solve rho. Um, but before we can solve rho, solve mo natin yung AS. Ang AS natin is anim na 25 mm. 625 mm. So this is 6 times the area of 25 mm pi times 25 squared, pi d squared over 4, right? Over 4. Okay. So we have in ES 2943.75. That means we can solve our actual row. Our actual row is 2943.75 over 300 times 500. This is equal to 0.01963. Okay. Let me add. So here, our row is less than row balance. Okay. What does it mean? Di ba yung row balance natin, if you can remember, ang raw balance is ito yung indicator natin na sabay mag-fail. Okay? So mag-yield yung steel at saka mag-fail rin yung concrete. So if babaan pa natin yung number ng rebar, iliitan pa natin yung area ng rebar, so that means siya una mag-fail, ang rebar mag-fail kung mas mababa pa sa raw balance. Okay? Pero kung marami yung rebar, that means ang raw, kasi S over BD, ang raw is greater than the raw max, then ang mag-una fail is yung concrete. But if raw is less than the raw balance, meaning mas maliit siya sa standard natin na raw balance, meaning that means siya mauna mag-fail ang reinforcement. So kung mauna fail ang reinforcement, that means in the capacity of the concrete, that means that our Fs, yung stress ng concrete, maatay niya talaga yung Fy. Okay, maabot niya talaga yung Fy. So from that, we have the formula to solve for Mu. Ano yung Mu is equal to phi Mn, where phi Mn is equal to phi times 0.85 of Fc prime AB times T minus A over 2. Okay, yan ang pinaka-basic na formula. So, di ba, ang raw, going back to this equation here, ang raw natin is less than raw balance. And then, so, ang steel natin is mag-fail. I mean, mag-fail siya una compare sa failure ng concrete. So, that's why maabot niya muna yung Fs, yung maximum stress niya, maabot niya yung Fy. So, in that case, since mauna fail yung yung steel, that means this one is tension controlled. Kasi nga sa couple, the weakest capacity, siya yung mag-identify ng ang pinaka-weak sa kanila, siya yung mag-identify ng maximum na kaya nila. Okay? So, let's say si concrete, kaya niya ng 50 kilonewton, si steel, ang kaya niya lang is, sorry, si concrete is kaya niya 100 kilonewton, si steel, kaya niya is 50 kilonewton lang. Kung magsabay sila, kasi nga reinforce sila as one, ang maximum capacity lang nila is yung 50. Although kahit kaya pa ng concrete yung hanggang 100, pero is couple kasi sila eh. Okay? So if one fails, the other will follow also. Ganun siya. So, um, our fee here, so since this is tension controlled, our fee is equal to 0.9. So, ano yung hanapin natin dito? Meron na tayong fee, FC prime, AB, meron na, D, A na lang, ang A. So, saan yun makukuha yung A? Di ba, ang A natin is makukuha dun sa summation of forces along horizontal. That is equal to 0. That is C is equal to tension. Compression is equal to, ano yung compression? 0.85 FC prime AB. This should be equal to tension of AS FS. Okay, so we can put the value 0.85 of FC prime. I forgot FC prime 28, 28, and then unknown yung A. So let's solve for A. And then yung B is 300 equal to AS. We have AS 2943.75. 2943.75 times FS. Ang FS natin here is equal to FY. Okay? Kaya ang FY natin is 4, forgot. Sorry. 415. So this is 415. So from here, we can solve our A. So our A is 170.69 mm. Nakakompleto na yung, wala pa pala, meron pang FS. We need to solve for FS. We have C. C is A over beta 1, right? Kasi we need to solve for, oh, I'm sorry. This one fee is not necessarily zero point 0.9 pala. Okay. Hindi pa siya totally, let's say, we need to solve kung naabot niya talaga yung breaking point ng steel. Okay. So C is A over beta 1. This is 170.69 over beta 1.85. So this is 200.81. Dito pala mag-decide, I'm sorry. Dito mag-decide ng ano, kung tension control. FS, yeah, it is tension controlled, but the value of phi is not necessarily zero point 0.9. So in between pa siya ng ano. So we have 600 D minus C over C. So we have 600 times 500 minus C, 200.81 over 200.81. So ang FS is 893.95. Okay, so here our Fs is less than 1000 megapascal. So kung less than Greater than 1000 megapascal, automatic 0.9. Okay. But if less than, um, diba tatlo yun? We have 0.65 and then meron tayong 0.9. So this one is purely tension controlled. And then in between that one, ito 0.65, ito yung compression controlled. Okay? So in between that one, pag greater than, ang Fs natin is greater than 1000 megapascal, automatic 0.9. But less than 1000, then we have the formula for phi. Gamitin natin yung formula na phi is 6.65 plus 0.25 Fs minus Fy over 1000 minus Fy. So here we have 0.65 plus 0.25. Fs is 893.95 minus Fy of 41 415 or 4, anyway, 415. Fy natin is 415. Yeah. 415 over 1000 minus 415. I'm not sure kung 415 or 414 sa book. Anyway, so 0.854 yung fee. So if you see here, ang fee natin, tension control pa rin siya, pero this is less than 1,000. So kaya in between siya ng 0.65 at saka 0.9. So our value here is 0.854. Okay? So we can now solve VMN. VMN is equal to uh, phi times 0.85 times FC prime AB D minus A over 2. So this is, our phi is 0.854 times 0.85 times FC prime of 28 times A is 300, B is 500. Tama ba? Sorry. Mali, mali, mali. Ang A natin is, ang A is not 300. B is 300. We have solved for A actually. We have so yeah, here A is 170.69. 170.69. B is 300. Ang D natin, yan. Ang D is 500 minus A, 170.69 over 2. Okay. So we have VMN. VMN, ito yung hinahanap na MU. Is equal to, of course, we will divide this to 1 million. So this is 431.57 kilonewton meter. Yan yung final answer. Okay? So let's solve one more problem. So we have here other problem. B, sorry, this one should be D. Okay. We have 300 by 500, 928 mm, and mhm, okay, 9 928 mm reinforcement, and then FC prime 34, and then 414 megapascal. So this is problem 2.3 in the book. Question is find MU. Okay. So since we have given the area of bar, we can solve AS. That is 9 times pi times 28 squared over 4. Excuse me. Okay. So the area is 5,538.96. So if we have the A, we can solve the row. This is 5,538.96 over BD. Okay. 300 by 500. Our row here is 0.03695. Okay. So let's check the raw minimum. Raw minimum is the greater, dalawa yung formula ng raw minimum, 0.25 square root of FC prime over Fy at saka yung 1.4 over Fy. So if I'm going to calculate this one, 0.25 square root of 34 over 414, this is 0.00352. About kung 1.4 Fy, this is 1.4 over 414. This is 0.0 338. So our actual row is actually higher than row minimum. So this one is um, row is greater than row minimum. That means this one is adequate section. Anong ibig sabihin? Meaning pwede siyang uh, we can go through with the design, with the calculation. Kasi kung ang AS um, actually, kung ang AS number ng rebar is less than raw minimum, so although we can proceed with the calculation, pero national, the NSCP suggests na meron tayong minimum na rebar. So, sir, what if sa actual, kasi minsan nga yung mga panday, kung walang engineer, diretso-diretso lang, lagay lang. What if nagkulang yung reinforcement? And then we are tasked to investigate the capacity of that beam. So, of course, i-reflect lang natin na kulang ang raw minimum. And then, kahit kulang yung raw minimum, we can still proceed with the analysis or determining uh, the capacity of the section. Kahit less than raw minimum siya. But whenever we are designing, dapat yung actual raw natin should be greater than uh, raw minimum. Okay? So this is actually the next step is yung start ng analysis. This one is parang preliminary pa lang ito. So you may not go through with this preliminary analysis. Okay, so we'll start with checking the if the steel will yield. So first step actually is check if steel yields. Okay, so we have raw balance. Ano yun? Ang basehan natin kung mag-yield ang steel sa raw balance. 0.85 beta 1 FC prime over Fy times 600 over 600 plus Fy. So, we have beta 1. Now, ang beta 1 natin is 34 greater than 28 megapascal. So, we need to use the formula for beta 1, which is 0.85 minus 0.05 over 7 times FC prime minus 28. So this is 0.85 minus 0.05 over 7 times 34 minus 28. So we have our beta 1 is 0.807. Okay, so we will use that in the calculation. So we can solve raw balance here, 0.85 times 0.807. Ang FC prime natin is 34 over 414. And then we have 600 over 600 plus 414 is equal to 0.0333. Okay, so that's our raw balance. Now we have solved the raw here 0.036. So what does it mean? Ngayon, in this case, ang raw natin is greater than raw balance. So kanina, ang raw is less than raw balance. Ngayon, greater than. So what does it mean? That means still does not yield. So if still does not yield, Fs is not equal to Fy. So kung ang still does not yield, that means phi is equal to 0.65. Okay? Kasi hindi naabot yung failure ng steel. So that means weaker yung concrete natin kaysa sa steel. Kasi nag-fail na yung concrete before pa ng failure ng steel. So again, kung sino yung una mag-fail, siya mag-control. So this is compression control. Okay. Phi is, I will just write here, compression control. Okay. So actually we can have the formula for phi mn kasi ang hinanap is mu. Mu is equal to phi mn. Meron tayong formula na phi times 0.85 fc prime ab times d minus a over 2. Okay, but we do not have the value of a, and then we do not have the value of a here, so we need to solve for a. So paano yan? We have the formula, yung C is equal to tension, compression and tension, which is 0.85 FC prime AB is equal to AS FS. But remember, yung FS natin is not equal to FY. Okay? So how to solve for Fs? Fs is equal to 600 times D minus C over C. Okay? And then, so let's put that in the equation. We have 0.85 Fc prime, or can I write directly the value? We have 0.85 Fc prime 34 times A. Okay? Now, dito naman is in terms of C, yung Fs natin in terms of C. So we know the formula A is equal to beta 1C, right? So instead of writing A here, we can write beta 1. So our beta 1 here is 0.807 C times B. Okay? Take note, this one is beta 1C, yung A, times B. Let me move this one. So, ang B natin is, we have a value of 300. Ang AS natin, nakasolve na tayo ng AS, 5538.96. Okay, and then FS, yung FS natin is 600 times D is, ang D natin is 500 minus C over C. Yan. Then we'll solve for C. Okay, using your calculator, we can solve that C. I'll jump directly to the values, 304.673 mm. Okay, so that's our C. Then we can solve for A kasi ito yung kailangan natin. A is beta 1C. So this is 0.807 times 304.673, which has a value of 245.871 mm. Then, do we need to solve for Fs? Actually, no need to solve for Fs. We can solve directly the phi mn, which is our phi is 0.65 times 0.85 times A of 245.871. B is 300 minus D 500 minus A over 2, 245.871 over 2. Then let's divide that to somewhere here, 1 million. So we have phi mn is equal to 522.46 kilonewton meter. Okay, so that's how you solve the moment capacity. Okay, I want to solve one more problem. This is problem 2.10 in the book. So in this problem, um, we have the dimension of the section of the beam 250 by 460, Fy 276, Fc prime 20.7. This is reinforced by 325 mm bar, and the length of beam is 6 meters, simply supported. And now, mayroon siyang given a dead load na 680 Newton per meter. Okay? Ito yung omega dead load, 680 Newton per meter, including self-weight. So, hindi na natin kailangan i-solve pa yung self-weight. I mean, i-add sa additional, i-add natin yung self-weight dito, including na ito, 680. So, the question here is, what is the maximum live load that can be applied? Okay, ito. What is the maximum live load? So, anong approach natin yan? Anong approach natin? Um, di ba, ang approach natin dyan, kung given ang hanapin natin yung load, di ba mayroon tayong formula na ah, MU, kung mayroong, ang load case natin is dead load and live load lang, the load combination for MU is 1.2 M dead load plus 1.6 M live load. Okay? So we can compute for dead load the moment created by the dead load, and then we have also for live load, then MU. So pag ma-solve natin itong MU, ma-solve na natin itong live load dito. Okay? So for simply supported, ang moment is equal to omega L squared over 8. In other words, this is 1.2 times DL. DL times 6 squared over 8, parang ganyan, plus 1.6 um 1.6 live load. Let's say LL live load, distributed live load siya, times 6 squared over 8. Okay? Ito ang hinahanap. Ang, sorry, let's erase. Yan. Ito ang hinahanap, live load. So, we need to solve the MU first. Ano yung MU? MU is equal to phi mn. Okay? So, paano yan? Meron na tayong reinforcement at saka section. So, ano yan? If you can remember, we'll start with the raw balance. Okay? Check na natin kung mag-yield ba yung steel. Okay? So, i-compare natin yung actual raw kasi meron tayong rebar, actual raw to raw balance. So, we need to solve the actual raw. This is AS over, wait. Solve muna natin yung AS. Yung AS natin is 325. So 3 times pi times 25 squared over 4. This is equal to 1471.875 mm squared. Okay, so we have a rho is equal to AS over BD. So this is 1471.875. Our BD is 250 by 460. Okay, our rho is 0.01280. Now, we will compare that to the raw balance. Raw B is 0.85 beta 1 FC prime over Fy times 600 over 600 plus Fy. So our beta 1 here, our Fc prime is 20 less than 28. So this is 0.85. So we have 0.85 times 0.85. Fc prime is 20.7 over Fy, 276.5. 276.5 times 600 over 600 plus 276.5. So our raw balance is equal to 0.03703. Okay, so let's compare raw to raw balance. So that means raw is less than raw balance. What does it mean? Kung less than raw balance, meaning still yields. And that is Fs is equal to Fy. So, ang maganda kung ang Fs is equal to Fy, we can use directly yung formula na 0.85 Fc prime AB is equal to AS Fs. Yan, diretso na natin magamit yung value ng Fy here. Okay, to solve for A. So, madali na lang. Unlike yung previous example natin, ito, kunuha pa natin yung value ng Fs here. Yan. At saka value ng A. And then yung equation natin medyo complicated. So, we can put 0.85 Fc prime 20.7 times A. Ang B natin is 250. 250 equals to AS area of bar 1471.875. 1471.875 times Fs yan. Yan, ito na yan. Diretso na natin magamit 276.5. So we can have A is equal to 92.52. So, meron pa tayong problema dito yung fee. Fee. So, yung fee, yan. Paano natin makuha? I-check natin sa Fs. Okay? Solve natin yung Fs. Fs is 600 times D minus C over C. Meron naman tayong C, di ba? masolve natin yung C. C is equal to A, di ba? A equals to beta 1 C. So, ang C natin is 92.52 over beta 1, 0.85. So, ang C natin is 108.847. So, we can solve Fs here. 600 times ang D natin is, forget again the D, 460 minus 108.847 over 108.847. So, ang Fs here is equal to 1935. So, this is greater than 1,000. Diba? Ito yung baseline natin, 1,000. So, pag greater than 1,000, that means phi is equal to 0.9. Okay? Now, pag hindi, pag less than 1,000, we'll use the formula for phi. This one is clearly tension controlled. So, we can solve phi mn now. VMN is yung phi times 0.85 FC prime AB times D minus A over 2. So we have 0.9 times 0.85 FC prime. Kalimutan po ko. 20.7. 20.7. Ang A natin is 92.52. Ang B is 250. Ang D is 460 minus A over 2. A is 92.52 over 2. So, we have, of course, divide natin ng 1 million. So, we have VMN. This is equal to MU actually. So, 151.54 kilonewton meter. Okay. So, we will compare this to MU. Remember, MU is equal to 1.2 M dead load plus 1.6 M live load. Okay, so we can write here 151.54, okay, times 1.2. Ano yung M dead load? Omega L squared over 8, right? Ang dead load natin is 680 Newton meter. So that is 0.68. 0.68 kilonewton meter, ha? In terms of 0 omega times 6 squared over 8. Yan. Plus 1.6 times, we can say live load multiply by 6 squared over 8. Yan. Okay. Then, using a calculator, we can solve live load is equal to 20.537 kilonewton per meter. Okay. Now, so I have solved, I think this one is sufficient for example sa klase natin. So I have added 4. And then, so marami pang example sa book which I encourage you to answer and keep answering. And, even just following yung mga examples. So, huwag niyo lang tingnan. Huwag niyo lang tingnan kasi good for expert lang yun na technique yung titingnan lang. Ako, ginagawa ko before is kung kaya ko man lang yung yung bagay kung ma-imagine ko lang yung sagot, then hindi ko na iso-solve. Pero pag hindi ko pa ma-imagine yung sagot, yung hands-on ko talaga solve. When I took yung physics na subject before, so yan, ginabasa ko lang muna yung problem. Pag ma-solve ko sa mind ko, i-skip ko na. Pag may problem na hindi ko ma-solve sa mind ko, ayan, sinusulat ko talaga. Now, this one could be new kasi sabi ko nga, yung designing is just application of analytics. Kung analysis lang, yung mathematics, pwede nyo tingnan-tingnan lang. But this one, it needs your patience. Na kailangan nyo talagang isulat yung step by step to be familiar with the methodology. Kasi magulo masyado eh. Kita nyo ang daming formula, saan ba ito gamitin, kailan gamitin ang mga formula. So I encourage you to keep answering so for you to be familiarized, to be familiar with the flow of the calculation. Okay. So our next topic will be T-beams and doubly reinforce.